Hi, my name is Markus Grün and I'm here with Keysight at OFC 2024. The AI demand is accelerating the network data center market. Therefore, we see new trends emerging faster. This year, we are proud to present you some new and interesting demonstrations around our comprehensive portfolio. So please have a look with us around our booth and meet our experts talking about these demonstrations. One of our highlights is the PCI Express over the optics, going by an LDO device. But maybe Adrian, why don't you talk more about this demonstration?
Yeah, sure, Markus. So, as you know, the size of the AI cluster is growing, and there is a need to extend the PCIe interface's reach. So the PCIe consortium has recognized this need and formed a new optical work group to tackle this challenge. Here, what Keysight is doing is basically showing a feasibility concept of a low latency, low power PCI 7.0 over optics. So for this, we use the MAT50 BERT as a PCI 7.0 compliant transmitter and receiver. And we are using technology, linear pluggable optics, which has been developed for Ethernet. And we are using it to transmit a 64 gigabaud PAM4 signal over the fiber. This linear pluggable optic consumes 40% less power than its real-time counterpart. And at the end, the whole optical I/O here consumes only 9 picojoule per transported bit.
Further to this, we are focusing on emerging test needs in the data centers, such as linear drive optics, validation of 224 gig, the pathway to 448 gig, and 800ZR.
Hi, I'm Paul, and today we're showing you physical layer test solutions for linear pluggable optics, sometimes referred to as LPO or LDO. Linear pluggable optics are one way of significantly reducing the power consumption and cost of data link transmissions to meet the needs of AI applications. We're featuring here today our G800 traffic generator and the DCA sampling oscilloscopes to characterize the signal integrity at ports TP1A and TP4 and port TP2 optical of this linear drive transceiver here. This includes new measurements such as EECQ and CEQ as defined by the OIF CEI 112G linear standard, which is currently under development.
Hi, my name is John Calvin. We're here today testing some early silicon here to the 802.3 DJ specification. This is a test specification that is evolving to support the 1.6 terabit per second sort of link speeds. And right here we have a PHY that's actually putting out a 212 gigabit per second electrical signal. And we're validating it with an 80 gigahertz UXR instrument behind me here. You can see a series of measurements up here. We have an eye diagram, as well as jitter decomposition and SNDR values. One of the unique things about the real-time architecture is that it has an oversampled architecture, real-time system, the way it works. And we're able to do clock recovery and signal processing on the system, which right now is a bit of a challenge elsewhere in the measurement space. So we're doing jitter decomposition. We're looking at around 120 milliuan of J4U. EOJ numbers here about 13 milliuan, and SNDR numbers are around 31 dB. With that, I'll introduce my colleague Ellen. Ellen will tell us more about the receiver tolerance testing. Thank you.
Yeah, thank you, John. So on the left side of this demo, we want to show how you can characterize your receiver for 224 gig. Here's the M8050 high performance BERT. And we are generating here a pattern stream, and that's traveling through the ISI channel board from Keysight to add insertion ISI. And then we are injecting here Gaussian noise after the channels. And this is all to stress the receiver under test on our partner's evaluation board. Everything is controlled from our user interface. And you can monitor the BR performance of the SerDes chip by the built-in error counters. Thank you.
Hi, I'm Fabio Pitala, product planner at Keysight Technologies. While the deployment of 800 gigabit per second coherent optics will continue in earnest in 2024, a new standardization project named 600ZR and targeting next-generation coherent optics at 1.6 terabit per second has recently started. Keysight solution allow to test coherent pluggable modules from physical layer up to layer 3. The N4391B optical modulation analyzer is used to measure physical layer transmitter impairment and to quantify the system performance by using different metrics like BR or EVM. The RS1-800G network tester is used for layer 1 to layer 3 testing for 800G, 400G, and 100G with PAM4 and NRZ signaling. All required spec types and an array of in-depth performance statistics are included on a single platform.
Hi, my name is Greg Lecheminant from Keysight Technologies. Today we're showing our AWG and our DCA products, which are used to both generate and measure very high-speed signals. This is similar to the setup people are using to test and show their 200G lanes, but today's focus is on pushing beyond 200G. Both the AWG and the DCA are capable of operating up to 180 gigabaud, providing researchers the critical capability they need to operate up to 400G, as shown by this modulator, which is operating at 155 gigabaud with the waveform that we see here.
Besides that, our capabilities of photonics integrated circuit tests are presented here at OFC.
Hi, my name is Michael Königsmann. I'm an application specialist for photonics in Keysight Technologies. Testing at the wafer level or die level has become indispensable for verification of integrated photonic designs. Here we show a setup that can do automated polarization, wavelength and frequency dependent tests as well as DC parametrics of an optical chip that is mounted on a mono probe station from form factor. The chips are considered to be a cornerstone in the evolution of data centers to 1.6 terabit.
As you see, with our comprehensive portfolio, we got you covered for all current and upcoming test and measurement demands in the data center industry. So do not hesitate to reach out to your Keysight representative to learn more about how we could support you. Thanks for watching and see you soon.